Hello and welcome to this webinar on must-have projects for your data science and machine learning portfolio. So let's get into it. First thing, what is a portfolio project? Now, this is a question that you might have. Okay, what's the difference between a project that I've done and a portfolio project? So a portfolio project is something that you have built on a large and unique real world data set. Okay. So if there is this data set like the Titanic data set that you have on Kaggle, or maybe the MNIST data set for deep learning, or maybe some other data set that is used in a popular course, then that is not something that you can put up on your resume as a portfolio project. So it should be a unique data set, which is not to say that there should be no projects on that data set yet. It simply means that it's not something that is used very, very commonly. And second, it should be a large data set, which means it should contain at least tens of thousands, potentially hundreds of thousands or millions of rows of data. You should not be putting up a project on your resume with a few hundred rows of data, because that does not demonstrate any reasonable level of skill at all, because that's something that you can do just by following along with a small tutorial, right? So make it large and make it unique enough that it's not something that is used in a common course or all over the internet. Another example of this would be the IMDb dataset for movie reviews. That's something that is used in all courses, so I would avoid that. And the IRIS dataset in scikit-learn is another one. So make sure that it's large and unique. The second thing is that your project should demonstrate mastery over the skill set that you want to talk about in the project. For example, if you're doing a data analysis project, then that should demonstrate that you can process a large data set, you can clean it, you can deal with missing values, you can deal with invalid values, you can deal with different types of data like numbers, categories, dates, locations, etc. And you can create different types of visualizations, 5, 6, 10 different types of graphs. You can make them interactive. You can add a bunch of other things. You can put graphs on a grid and show multiple things at once. So it's important that you demonstrate that you're really good at this stuff. It's not enough to maybe just tick the boxes and just do a few charts here and there and pick a simple data set with just one type of data. Make sure that there is enough variety in the data and in the work that you're doing, so that it demonstrates that after looking at your project, I feel that you have all these skills. And make sure that you've derived some interesting insights. So you've done something unique. You've put your own flavor of work into that project. Then your project should have good code quality and documentation. The output of your project itself is not that important, because it's not something that is going to be used in the real world, but the code that you write to get that output is probably more important. It's about how you do the project than what you do in the project that matters. So make sure that you're writing good code, make sure that you have proper variable names, make sure that you have written functions wherever possible, make sure that you've not put a lot of spaghetti code and a lot of for loops inside if loops, etc. Make sure that your functions are small. Make sure that you're not doing a lot of nesting. So this is the kind of code that you will write in production at a company. And that is the kind of code you should put in your project. And you should document your project, and you should put up your project somewhere online for people to see, right? That is when you can call it a portfolio project, when you satisfy all these criteria. And finally, your project should be published online, where somebody can easily find it. They can read the code, they can read the documentation. Preferably for data science, a Jupyter notebook is a great format, and you can put up a Jupyter notebook on platforms like Jovian or GitHub or elsewhere. And your project should also be linked from your resume. When you apply to a job, and first thing you should do is you should talk about that project. You should mention a few lines about that project. You should talk about the size of the data. You should talk about what skills and what techniques you applied. And you should talk about what you achieved in that project, and then provide a link to that project, and clicking on that link should open up that project where I should be able to read all your documentation and look at all your code, which is very well written, and see that you've derived very interesting insights from a large data set. So the idea here is that it is something that should impress a potential employer. It is something that should convince them that you have the skills, that you have what it takes to be productive with these skills. Okay. A good portfolio project can make the difference between you getting shortlisted or not getting shortlisted for a job. A good portfolio project can make the difference between you having a very tough interview versus you having a very easy interview where you just have to talk about the project. So projects are really, really important, especially when you're trying to break into a domain. Now, why should you build portfolio projects? the first thing is that you learn by doing. When you're building something, that is when you actually have to test your understanding of every concept that you've learned. It's not enough to watch videos. It's not enough to just follow along with tutorials. When you apply it to a real problem, that is when you learn the most. You learn swimming by jumping into the pool. You learn driving by actually driving a car. In the same way, you learn data science by building projects. The second thing is that this helps your resume stand out. When you apply for a job, you're one of 200 people who have applied to that job role. And when a potential employer comes across your resume and they see quickly that, oh, you have 3 great projects in exactly the areas that they need you to have skills in, and they can click through and check out some of your projects, they are immediately convinced that this person might be a good fit for the role. Then it also provides, obviously it provides evidence of your skills, because now I don't have to question whether you have these skills. Anybody can list out a whole set of skills on their resume, but it takes work to create a unique project that you've documented and put up online that I can see. So it provides strong evidence that you have the skills already that are required for the job. And a project is also a great substitute for lack of experience in a domain. So we often get this question, all the jobs that I see require 2 to 3 years of experience. What do I do? Build some good projects, put them up on your resume, and then apply to a job, even if it requires 2+ years of experience. You will be surprised. In a lot of cases, your resume will get shortlisted, and that question of experience will not even come up if people have already seen your project. And finally, one last thing is that a project can help you acquire domain expertise really quickly. Let's say you're interested in applying to a company which is working on finance and you're applying for a data science role. So you may not have any prior experience in finance, but if you pick a data set, a financial data, and you build a project on that, maybe you build an exploratory data analysis project, maybe you build a machine learning project, and then you put that on your resume, and then you apply to a company, they're going to look at the resume and think, okay, this person has worked with the kind of data that we have at our company. He's definitely a better choice compared to all the other resumes we have received. So similarly, whatever domain you are interested in applying to, let's say you're interested in energy, let's say you're interested in autonomous vehicles, do projects that are relevant to that domain, because that's how you will learn the basic concepts that you require in that domain to be productive as a data scientist or a data analyst. And that's how you will provide evidence to a potential employer. So they're very important. And that's why we talk about projects so much in our courses and our boot camps. Now, where do you find datasets for these projects? And we'll share these links with you. The best place to find datasets is Kaggle datasets. Just go to kaggle.com/datasets. And here, search for datasets on any topic and you'll find them. And we have tutorials on how to find datasets as well. And another good place is Google Dataset Search. Now, Kaggle Datasets is a set of crowdsourced datasets that people have uploaded to Kaggle, that single platform. Google Dataset Search can let you search datasets across the entire internet. Now, if you're looking for something very unique, very specific, Google Dataset Search might help. If you're looking for just a generic dataset that's large in size, that contains a whole variety of data, then Kaggle Datasets is a good option for you to go ahead with. And finally, another couple of places you can look is the UCI Machine Learning Repository. This has a bunch of datasets more focused towards machine learning, classical machine learning algorithms. And if you're interested in using financial data or economic data, then you can go ahead and check out places like World Bank. And there are a bunch of other online platforms as well, which collate this data and offer it in a downloadable format. So for most projects that you will build, the first one, Kaggle dataset, should be sufficient. If you have a very specific domain that you want to target, then maybe Google Dataset Search. And specifically for machine learning, you have the UCI/ML, and then you have the World Bank for financial data. All right. So that's just a quick introduction on what portfolio projects are, why they're important, and where you can find datasets. And let's see if we have any questions at this point. So we'll check a few courses out. We'll check a few questions out and see if there are any questions. Okay. So I can see here, are we getting a recording of this session? Yes, we are recording this session. Then where can we find the courses? Well, we have courses on jovian.ai/learn. So I'm going to drop that link in the chat. Yeah, so I'm dropping that link in the chat. Is there a website where we can showcase these projects? Well, you don't need a portfolio website, but you can put it up on your GitHub profile, on your Jovian profile, so in a bunch of different places. Okay, moving ahead. So let's talk about the first project, the first must-have project for your data science and ML portfolio. The first project is exploratory data analysis and visualization, because this is the bread and butter of pretty much any data science role, whether you're starting out as a business analyst, data scientist, product analyst, decision scientist, machine learning engineer. At least half of your time will be spent downloading data from some data sources, then cleaning it, combining data from multiple data sources, converting data from one format into another, analyzing, extracting features out of columns and things like that, right? So this is one of the most important projects. But what is an exploratory data analysis project? How do you build it? So the first thing you do is pick a large real-world data set, potentially tens of thousands or even millions of rows and having many different types of data. Then perform data preparation and cleaning, which means load it up using Python and its ecosystem of libraries like pandas and NumPy. Pick some interesting columns, do some cleaning. If you have some missing values, deal with those. If you have some outliers, deal with those. If you have some invalid values, deal with those. If you have some data that is supposed to be dates, but is represented as string, convert them into dates, maybe extract parts like day, month, year, etc. out of dates. So perform data preparation and cleaning, and then analyze the data. So analyze every column individually, one by one, create histograms for numerical columns, create box plots for categorical columns, maybe create bar charts, maybe create heat maps, correlation maps, things like that. So analyze one column at a time, then analyze combinations of columns, then maybe analyze 3-4 columns at a time, use scatter plots, use tree maps, use all kinds of interactive graphs that you can create. So analyzing and visualizing the process data is the next step. And then ask questions about the data. So now you're sitting on a gold mine of information, and you should be in a position to ask interesting questions about that information. Let's say you have some financial data. Let's say you have sales data for a company. You should be asking which was the best month, or you should be asking if there has been a constant growth in the sales, or has that gone down, or which was the best store, which store produced the best sales. You can ask all such kinds of questions. If the sales were low in a particular week, why was that? Why was sales zero on a certain day? And sometimes these questions will be answered just by looking at the data itself, by visualizing it, analyzing it. But sometimes these questions will require you to do some additional research, maybe get some additional data. And those are the most interesting kinds of questions. But ultimately, you should get answers to all these questions, again, by analyzing and visualizing the data. And you should then summarize all the interesting insights that you've obtained from the data. And finally, you should clean up all your code. You should make it presentable. You should document all the work that you've done, and you should then publish it online. That is what it takes to build an exploratory data analysis project. So let's look at some examples of EDA projects. So here's one. This was done by Rohan, who was part of the bootcamp, the data science bootcamp that we run. So Rohan actually used his own data. He didn't use an online data set. He downloaded his listening data from the site last.fm, and he looked at probably three to 4 years of data. You can see here that he looked at data from July 2018 to July 2021, and he had track-wise data for every track that he listened to, and he had 73,000 rows and 19 columns. So here is one thing that he saw that he had a bunch of different artists that he listened to. He would listen to artists, a bunch of solo artists. He would listen to a bunch of bands. Among solo artists, he had a bunch from the USA, a bunch from the UK, a bunch from elsewhere. From USA, he had people from other states, California, New York. So this is a nice chart showing the distribution of what kinds of artists he was listening to. Then here is the information about the duration of the tracks that he was listening to. So in most cases, the tracks that he was listening to were about 2 minutes in length. That was the average, but there were several short tracks and there were some really long tracks as well. So that's an interesting histogram and a box plot. Here he had information about the time of day. So he was definitely listening more in the second half of the day and less in the mornings. And this is again an interesting chart. So these are all interesting ways to visualize data. And similarly, here's information about the month and the weekdays and the month, how the listening activity looked. And here's information about the average number of new artists that were discovered. So when he started out, he obviously started out with a lot of new artists, but slowly over time, he had this sort of zigzag pattern where he would listen to maybe 5 to 10 new artists in a month. So it's a great analysis and a lot of great insights that are captured, and we'll add a link to all of these projects. In fact, let me do that right now. So I'm going to drop in a link to all the projects that I'm showing you right now so that you can go through it. You can go through the detailed project. I'm just showing a quick overview of the project here. Let's see. Yep. So this is a great example of a project, good data set, lots of interesting graphs, lots of interesting insights. Here's one more. This was done by Pankaj, and here he is performing the analysis of 7 million plus companies. So he went to a website which provided information about 7 million plus companies from around the world. And he had information like when these companies were established, how many or which country they were based in, what was their revenue and things like that. And here he was able to find out that most companies, and this data went back a long way even to 1800s. Here he was able to find out that most companies have been established in the last 20 or 30 years. And he could also see that some industries were more popular in the early 1900s and some industries are more popular now. So how the trends of industries have changed over time is something that he visualized. He also visualized it geographically, and he saw that most companies were in the USA, but of course, there are companies from all parts of the world. He looked at the top 10 industries. He also looked at how the information technology industry has grown in different countries. So this is just, again, a small selection of charts. And I believe some of these were also interactive charts where you could select a country and see the information created using tools like Plotly and Folium. So again, a great project, huge data set, a lot of analysis, a lot of work went into this. So clearly, this is something that's going to stand out when you present it on your resume. Here's another one, weather and renewable energy analysis. Again, 5.6 million rows and 20 plus columns containing information about the weather, information about temperature, information about how much energy could be generated. And this is information for India. And you can see here that we have the distributions of temperature. So in most parts of India, you would see that between 20 to 30 degrees is where most of the time temperatures lie. And there was also a description of the weather, and that's where there was this word cloud describing that you had clear sky and light rain and things like that. Then here is a relationship between the sea level pressure and the temperature. So it's useful to study the trend between these and also to study these how the sea level pressure and temperature varies across months. So it's interesting data to look at. Here's information showing cloudiness of each state in each month, again, state-wise, month-wise. Here's information about the top 10 hottest cities in India. And here is information about the maximum temperature. So a lot of information that you can convey visually, a lot of insights to be drawn from this data. Again, a great project, a lot of data. So you had to use tools like NumPy, Pandas, Seaborn. You couldn't do this any other way. So this is a project by Prashanti. And similarly, here's another project, e-commerce customer behavior. This is even bigger, 42.5 million rows, 9 columns, analyzed again using the same set of tools. So this is information about the visits during a month from the start to the end of the month. So clearly mid-month is when people do a lot of shopping. Visits by day of week. Clearly Sunday is a time when people do a lot of shopping in e-commerce. In terms of the revenues, you can see here smartphone was one of the biggest chunks of revenue. So again, very interesting information to study. Electronics make up a lot of the conversion. So a lot of people who go on e-commerce site to buy electronics actually end up buying them. Apparel has a very low conversion. There's a lot of browsing going on. So clearly there's, again, a lot of information in terms of the hour of the day when people are shopping. So great project. And we've dropped the full link in the description so you can check it out as well. So that's what an exploratory data analysis project looks like. Of course, it's a small selection and you can do a lot more in this process. So that's must-have project number 1. And now let's move on to must-have project number 2, which is a business intelligence dashboard. And this is the kind of project that may not even require you to write a lot of code. But this is important because most companies want to have dashboards where they can look at actionable metrics and insights coming from live data. So your exploratory data analysis is great for preparing a report. But if you want to have a dashboard created using live data, then that has to be created using a business intelligence tool like Tableau or Power BI. And typically you have to connect Tableau or Power BI to a database. So a SQL database, or maybe an Excel workbook or a Google Sheet or something like that. So some live data source connected to a business intelligence tool, and that then turned into a dashboard. And this is what some business intelligence dashboards look like. Let's look at how to build it. So the way you build it is, first you pick a SQL, CSV, or Excel dataset, and you can find a bunch of these online. Again, we will share the links to all the sources for finding datasets. Let me share that once again here. So you pick a SQL, CSV, or Excel dataset, and then you perform data cleaning, you perform data analysis, and then you perform pivoting. So you do some analysis using SQL or just using Excel, not necessarily using Python. And then you import it into Tableau or import it into a tool like Power BI or Looker. Tableau is the one we recommend because it has a free version that you can use, and you can also publish your work online. And then you create an interactive dashboard containing a bunch of different graphs, maybe some controls, maybe some filters to show some insights. And finally, you create and publish a dashboard online. So Tableau has something called the Tableau Public Gallery that you should check out, where you can see examples of thousands of dashboards that have been created by people who use Tableau. And you can publish your own dashboard here as well. So again, let's look at some of the example dashboards created by students of the Jovian Data Science Bootcamp. So one dataset that we had recommended was this bookshop dataset, which contained information about sales at a bookstore over a year. And here you can see information. This was a dashboard created using Tableau and published to Tableau Online. And I'm going to drop in the links to all these dashboards into the chat as well, so that you can go through it. So here you can see information. Here you can see information about the top 10 selling books. So these are the number of sales for the top 10 books. Here you can see information in terms of the number of, in terms of the marketing money spent per genre. Here you can see information about the award-winning authors with the most number of places, or countries of residences of authors, month-wise checkout trends, and things like that. So this was a live dashboard. You can actually just hover over different things to reveal more information. So I'm just taking a screenshot here. And there are also controls where you could actually select a specific title, or you could select a specific year, and you could get data out of it. Now, this same data set was also used by other people. So here is another dashboard, which looks completely different, which was built on the same data set. So you don't always have to use a very unique data set on which there are no projects. You can use a data set that has been used by somebody, but just make it unique. What you do with the data set is up to you. There's an infinite number of things that you can do. And here is another example. This shows you more time series data, information like the sales by month, information like total sales by, I believe, total number of sales, and then total revenue by month. Here we have information about total sales by genre, total sales by author. So this is a very sales specific dashboard. Here is yet another one, which is again created using the same dashboard. So this one has a bunch of summaries at the top. So it has some filters. Using the filters, you can select a time period, and it will tell you what the total sales were, what the total number of checkouts, orders, items, etc. were. Again, all interactive, everything you can hover over. So check out the links. And also just information about quarter-wise revenue per genre. So again, a great example of the kind of business intelligence dashboard you should have. So typically in the dashboard that you create, your data set should have at least tens of thousands of rows of data. You should try to create at least 4 or 5 different types of graphs in your dashboard, if not more. You should make sure that all those graphs are interactive, and you should also add some filters and drop downs and sliders and things like that, so that you can constrain the data that the dashboard applies to, and that provides even deeper insights. Okay. Here's another one. This is a sales pipeline dashboard created by somebody, which contains information like a number of open opportunities, which accounts are driving conversions, average sales, average deal size, etc., on some sample data. Here's another data set somebody created using information about the Parkinson's disease in the UK. All of this was done using free online data sets. So, and you can go and check out all these graphs and all these dashboards on Tableau Gallery. So business intelligence dashboard is going to be important because you will have to create something for other stakeholders, people who do not have the technical knowledge that you might have. and need to interact with your the work that you've done, with the analysis that you've done. That's what these dashboards are for. Okay, so we'll pause at this point before we talk about project number 3, and let's see if we have any questions. Okay, here is one question. How many projects should a portfolio have? Well, 3 projects are, generally speaking, 3 projects are enough. So we've talked about 2 of these, and we're going to talk about the 3rd project in just a second. But specifically, if you're targeting a certain specific role, then you may need to replace or add 1 or more projects, which is also something that we'll talk about towards the end. Then what else? What is the best algorithm to solve business problems? Well, there's no such best algorithm. There is always, what you should ask is, what is the best algorithm for a specific type of problem, right? So it depends on what business problem you're trying to solve. Just like there's no one best chart, there are 6 types of graphs, and each graph is appropriate in a certain situation. Similarly, different types of algorithms are useful in different situations. There's one JavaScript library which can be run in Python. I can't recall. Okay, so I believe you're talking about the Plotly library, which has a Python package. You can use it to create interactive charts within your Jupyter notebooks. And check out the links to the exploratory data analysis projects that we have shared. Okay, then there are a few more questions. How do recruiters differentiate between a good project and an average one? So I just mentioned that if you should provide a link to your project so that they can check it out. Then the quality of code should be high, the documentation should be good, the data set should be large, and you should mention all that in your resume as well. The size of the data set, the skills you applied, and the results you obtained. What else? Well, can a Mac user use Power BI? I think so. I think they have a web version and even a Mac version. Okay, I'm a beginner. I wanted to ask why and what is the need of data science from the view of a local businessman? What can we achieve with data science? Okay, hold on to that question. I will come back to that question at the end. But quick answer there is that you can understand what's happening in your business. You can understand how the sales are increasing. You can understand which products are selling more, like the bookshop data set that we showed. Have Jovian covered the topics on business intelligence? Well, we covered it in the bootcamp. We don't have a free course on it at the moment. Do Kaggle competitions count as portfolio projects? Yes, if you clean up the code, if you document it well, if you publish it online, maybe write a blog post or publish a Jupyter notebook with proper documentation, then yes. If you've just written some code and submitted, that's not going to count as a portfolio project. It has to be presentable. Okay, a lot of questions. So I'm going to come back to questions once we talk about must-have project number 3. So must-have project number 3. Any guesses here what this project should be? So the 3rd project that you must have for your data science and machine learning portfolio, as you might have guessed, is a classical machine learning project. So notice here, I'm not saying you should build a deep learning project. I'm not saying you should build a reinforcement learning project. I'm saying you should focus on classical machine learning, which means techniques like linear regression, logistic regression, decision trees, random forest, gradient boosting, SVMs, etc. Because 90% of the data that businesses have is tabular data, even though deep learning and video and images and text and all these things are creating a lot of hype these days because of the kind of advances that have happened in these areas. Most businesses have data that is sitting in some databases or some Excel sheets, is in a tabular format, rows and columns, is not even that large, is maybe tens of thousands, maybe hundreds of thousands of rows. And the best way to build models for these kinds of data is classical machine learning. One, because these models can be built easily. They are better explainable than deep learning models. And also the kind of tools that you have for building these models are also much more mature, right? So unless you're applying for a kind of a role which requires deep learning specifically, you should focus on classical machine learning techniques. So how do you build it? In this case, I would suggest pick a real-world data set from Kaggle, specifically a Kaggle competition that has already been completed. So Kaggle has data science competitions, which contains data from real companies that have shared data for competitors to build models on. So use something from one of the 200 plus competitions that have been conducted on Kaggle. Then formulate a proper machine learning problem. So identify whether it's supervised learning or unsupervised learning, identify what are the inputs, what are the targets, identify what is the evaluation metric, then prepare the input data for training, analyze it, maybe process it in whatever format required, convert from one form to another, perform some feature engineering, perform some cleaning, perform missing data replacement, scaling, etc. Prepare the data for modeling. Then then create features, and then train models, and then iterate. So you should not just train one model like a random forest and just leave it. You should train all different kinds of models, and then you should tune the hyperparameters of each of those models, and you should try to get to a point where you get to a good score compared to the leaderboard of that competition, or you get to a score that makes sense in real world applications. For example, if you are building a model for house price prediction, and the house prices are in the range of maybe $500,000 to $2 million, and you create a model which has a root mean square error of 500,000. That's pretty bad. If your predictions, if the range of your predictions is 500,000 to 2 million and your model is off by 500,000, that's very bad. But if your model is just off by 50,000, then that's probably not a bad model. That's actually pretty good. So you have to interpret the result that you obtain in the context of the real world problem and explain whether that model is going to be useful in the real world or not. This is something that a lot of people miss in machine learning. They get a data set, they train a model, they get some result, and they're like, I'm done. But your model has to be used in the real world by the company that you're going to join. So you have to explain why in this project you have done a good job and why the model is giving the results that it is giving. So you should also do a little bit of model interpretation. So you should summarize all of this, and you should document it, and you should clean up all your code, and you should publish it online. It's not enough to have a GitHub repository or a Jupyter notebook with a bunch of code not explained, with bad variable names and just no good functions, etc. So make sure that it is presentable just like you would present it internally within a company. Summarize your work, do your analysis, present your insights, and publish it online. Okay, so that's how you build a machine learning project. Here is a great example: Walmart store sales prediction. So this was a competition that was conducted on Kaggle. This was real data from Walmart, where they had information about a few hundred stores. They had 537,000 rows of data, day-wise store sales data across 14 columns. And the idea was to train machine learning models on this data and make predictions on new data for store sales, so that Walmart could accordingly maybe decide how much inventory to send to each store and things like that. So linear regression, random forest, GBMs, these were some of the models that were trained by Nicholas, who worked on this project. He was part of our data science bootcamp as well. And he was able to achieve $1,352 in weighted mean absolute error. And the store sales, I believe, were in the range of a few $1,000s to tens of thousands of dollars, the daily sales. So 1,300 was actually a great result. And he performed a lot of feature engineering and hyperparameter tuning, and he landed at the top 14% in the Kaggle leaderboard. So what you cannot submit to a Kaggle you cannot get on the leaderboard directly, but you can make submissions to a Kaggle competition that is already ended, and you can see a score, and based on the score, you can decide where you would have landed on the leaderboard. So in this case, this was a great result that he tried many different models and created a model or an ensemble of models that landed him with a score that was in the top 14% of the Kaggle leaderboard. So that's great. Here's another example: online ad click probability prediction. So this project was done by Deepa. She took 1 million plus rows and 10 columns of advertisement data. So this was advertisement shown on, I believe, like a social network kind of a platform. And she performed a bunch of feature selection. She did some imputing, scaling, encoding, so preparing the data for training. Then she used linear regression, random forest, gradient boosting models. And after trying out many different sets of hyperparameters, she was able to get to a root mean squared error of 0.25 using a random forest. So you were predicting the probability of the likelihood of somebody clicking on an ad. So if you think the person is going to click on an ad, the probability you should predict should be closer to 1. And if you think the person is not going to click on the ad, probability you predict should be closer to 0. Her predictions were off by just 0.25, which makes it really good. So the way this would be used is when somebody is putting up an advertisement on that platform, Then using this machine learning model by taking the inputs of all the information that is provided by the advertiser, the platform can tell the advertiser what is the probability that their ad will get clicked by a certain kind of user that they are targeting. And based on that, the advertiser can try different kinds of advertisements before they actually put some budget on it. So this is actually a very useful model in the real world. And the result that she obtained was a really good result. And this is how you should explain the result that you obtain in your projects. Then here is another one, credit card default payment prediction. This project was done by David. The idea here was looking at some credit card transaction data. Can you predict whether somebody is going to default on their credit card payment sometime soon? Again, 150,000 rows, 11 columns, tried a bunch of different classification algorithms and got to about 94% accuracy after 20 hours of hyperparameter tuning. So tried many different approaches, and that got him to the top 20% on the Kaggle leaderboard. Now that is an impressive project, large data set, great result, many different attempts, and you should check out David's notebook. I will link to it in the chat. So I'll add all the links to all the projects in the chat. You should check these out. These are very detailed projects and they've done a lot of work into it. They put a lot of work into it and they've done it. They've documented it really well. And that is the standard that you should set for any project that you are building. All right. So that is the third project, classical machine learning, that you should build. And typically these are the tools that you would use: scikit-learn, XGBoost, pandas. Here's another one, airline accident prediction prevention using ML. You can clearly see what would be the application of something like this. And again, had millions of rows of training data, had a very low loss after hyperparameter tuning, got into the top 25%. So that's why we suggest using past Kaggle competitions, because whatever result you get, you can benchmark it against the leaderboard. And if you're in the top 30, 40% of the leaderboard, your score, then it's a great result. It's a very usable result. And if you've then documented your work and put it up online, that is a very strong evidence that you are skilled at machine learning. And all the projects that you're seeing here have been done by people who are part of the Jovian Data Science Bootcamp and have now gone on to apply data analysis and machine learning skills into their jobs. So there was a question about where do you showcase your projects? A great place to showcase your projects is Jovian. So you can just go on www.jovian.ai and you can just sign in. So you can create an account and you can sign in for free. And once you sign in, you can actually put up all your projects here on your Jovian profile. So this is the profile from Manish, who again was also part of the bootcamp and is now working as a data scientist. And here you can see that if you've completed courses on Jovian, that is listed here. You can actually put up a video resume on Jovian. So this is something Manish has done here as well. Then you can put up information about your projects, the projects that you've worked on, and you can put up information about your work experience, your certifications, your education, and you can feature a bunch of notebooks as well and showcase your activity. So Jovian is a great place to showcase your data science work in the form of Jupyter notebooks, or even just link to other projects that you've hosted elsewhere. And if you want to build all of these projects, then, well, we run a data science bootcamp, which is focused exactly on doing this. So this is, you can just go on www.jovian.ai and you can just check it out. You can actually, we have a batch starting soon, in fact, starting in a few days. So you should, if you want to apply, you can go ahead and apply right now. And you have information about how the program works. All of that is listed on this profile. But if you do apply, you can also talk to one of our academic counselors. And what happens in the bootcamp? Well, we believe in learning by doing. That is why we focus a lot on projects. So what happens is bootcamp is divided into 3 phases, weeks 1 to 8, which is building the foundations, where you learn Python programming, you learn SQL and business intelligence. Then the first project you build is a business intelligence dashboard. You also build a project on web scraping. That's another topic, but business intelligence dashboard, that's one of the projects that we talked about. Then we focus on building the core skills, data analysis and visualization and statistics for data science. And you practice these skills by solving some assignments. And then you build a second project on exploratory data analysis, the kind of projects that we just looked at. And then we focus on machine learning. So you learn machine learning foundations. And then we also have a section on career readiness training, where we actually talk about how to prepare your resume, how to showcase projects on your resume, how to present each aspect of your project, how to link to your projects and all of that. And then you also build a classical machine learning project. So the 3 projects that I just talked about are projects that we have understood should be built after talking to hundreds of companies that are hiring from us. So we have 200 plus hiring partners, and we've looked at their job descriptions, their requirements, and we've designed the projects according to their requirements, according to the skills that they require in the data scientists and data analysts they hire. And then we've worked backwards from there, and we've then figured out what should be the curriculum so that you can build these projects, right? And that is how we were able to put together this 6-month curriculum, and that has helped at this point dozens of people successfully transition into data science. So it's a 24-week, 6-month program, and you need to spend about 20 hours per week, and you complete about 6 practical courses, 15 assignments, and 3 real-world projects. And the best part here is that we have one-on-one guidance and mentorship. So if you're stuck at any point, if you need help with building your project, if you need feedback on your project, if you need help picking your project topic, if you need help deciding what to do in the project, or if you're stuck somewhere and you just can't move forward, then we have live chat and call support. And we also then work with you on your LinkedIn, on your resume, and then we help you figure out what kind of role you should target. Let's say if you're targeting a particular domain, what kind of project you should build. So I believe, I remember one of our students, Saurabh, is working at Scriptbox. And since he had some background in finance, so he worked on a project where it was a financial data set, and he built a machine learning project on that. And that was helpful for him in applying to Scriptbox. Similarly, another project somebody worked on was a marketing project, was e-commerce data. And that project was useful in helping them land a job at MIQ, which is a marketing analytics company. So projects are really important, and that is really what is the focus of the Jovian Data Science Bootcamp. So do check it out. Head over to you can head over to jovian.ai and you can apply. We'll actually drop a link in the chat for the people attending the webinar. We do have some discounts going on for the last few seats in the November batch. And these are all the skills that you require to build these projects. So these are the tools, these are the skills that are used in real companies and thousands of companies around the world: SQL, Python, NumPy, Pandas, Matplotlib, Scikit-learn, Excel, Jupyter, Tableau. So these are exactly the things we use. From day one, you're writing code using one of these tools, you're building things, you're solving assignments, and ultimately you're building projects. And once you've done that, once you've built some good projects and you've done a little bit of interview preparation, it's actually fairly easy to get into data science, especially into the roles that seem like they require 1 to 2 years of experience, right? So if you're wondering what it will take to break in, you need to have these good projects. So just to summarize, what are the must-have projects for data science and machine learning? So exploratory data analysis, that is probably the most important project that you should build, because that's the bread and butter of data science. Then you have business intelligence dashboard, a live dashboard that you can share with other people, where they can select some filters, where they can browse through information, possibly coming from some Excel or maybe a SQL database. And finally, classical machine learning, where you take a large data set containing millions of rows or maybe tens of thousands at least, and then you clean it, prepare it, do some feature engineering, train some machine learning models. I also want to leave you with some optional projects. So people in the bootcamp also work on some optional projects, which we also are able to assist them with. Now, here's one you can build: web scraping with Python. A lot of companies require you to actually scrape data from different sites on the internet. So that is, again, a useful project that you can build. This is also something we do in the bootcamp. It's a smaller part, but it's, again, something that we focus on. And web scraping is also a great way for you to demonstrate your Python programming skills, demonstrate that you understand how to work with loops and functions and exceptions and things like that. Then if you are interested in deep learning, if you want to become a deep learning engineer or a deep learning researcher, then building a deep learning project is also important. So you can do this using PyTorch or TensorFlow. Now, typically, deep learning will not be your first role unless you already have maybe a computer science or a deep mathematics background. This typically is your second or third role. That is why we don't focus on it. But we do have a course on deep learning that you should check out: Deep Learning with PyTorch, 0 to GANs. So you can check that out as well. And then we have, you can also do some web development and deployment, because sometimes with machine learning work, you might also have to then deploy your project to the cloud. So you should go ahead and check out web development and deployment as well. Now, one thing you should do right away if you're interested in building these projects, is head over to our YouTube channel and definitely subscribe, because we are doing workshops pretty much every week or every other week. But scroll down on our YouTube channel and we have a bunch of tutorials on building projects. So I believe you can just head over somewhere to, okay. Yeah, head over into our live section and you will find a bunch of tutorials on building projects. So here we have a tutorial on web scraping. Here we have a tutorial on machine learning. So building a machine learning project from scratch. Now, of course, the skills that you require for building these projects, to learn these skills, I would suggest joining the bootcamp. But this is what the process of working through a real world projects looks like. So that's something that you can check out as well. Here is a tutorial on writing a data science blog post. Here's a tutorial on building a web scraping project. Here is a tutorial on building an exploratory data analysis project. So we have a bunch of these tutorials, but to learn these skills, I would also suggest come check out our data science bootcamp. And we have a bunch of other tutorials that you should absolutely check out as well. Okay, so let's see if I can just drop that link into the chat again. So I believe we have a link somewhere for you to apply. Let's see, or you can just let us know that you were. Yeah, so you can just use this link, and when you apply with this link, we'll know that you were part of this webinar, or when you're applying in your application, when we talk to you, you can also let us know that you were part of the webinar, and there's a discount, there's a promotion that we're running. So I hope this was helpful information, and I can see a lot of questions. So let me open up those questions. I'm gonna stop sharing my screen, and if you have questions, please post them in the chat. We'll go over as many questions as we can, but we'll try to answer as many as we can. Let's see. Okay. Do Kaggle competitions count as portfolio projects? Yes, Kaggle competitions do count as portfolio projects if you have documented them and put up your work online. Is data structures and algorithms important for data science portfolio? Not really, not really. A little bit is good. So more than specific data structures like binary trees, binary search, algorithms like graph algorithms, it's more important that you're able to write Python code. You're able to turn your thoughts into code. So just working with strings and lists. So just Python coding is important, but data structures, algorithms, all the advanced stuff, not so much. Okay, first set EDA examples. Okay, so the question was like, when we say exploratory data analysis, are we talking about Python's ecosystem of tools, or are we talking about Excel, Tableau, etc.? So when I say exploratory data analysis, I'm referring to Python, Pandas, NumPy, etc., because you need to demonstrate that skill. But when I say business intelligence dashboard, that's where I'm talking about using Tableau, Excel, SQL, because you need to have that skill as well. Okay, do we need to use Altair, or can we leave it? Well, I don't know. I'm not familiar with Altair, but it's not a very common thing that I've seen companies asking for. Where to ask doubts? Yeah, you can ask doubts here. You can post your questions here. How can we plot all the measures and dimensions together in Tableau? Well, that's a very specific question about Tableau. I would encourage you to check out the Tableau documentation, or we actually do cover this in the bootcamp, but it's probably too detailed for me to talk about right now. Okay, is Bokeh the best for interactive plot? I believe you're talking about the Bokeh library. Well, you can use any library that you find usable, that you are able to figure out how to use. My personal recommendation would be the library Plotly, that has a very nice Python interface, and it allows you to create interactive charts using Python. So I would suggest using the Plotly library for interactive plotting, and also Folium if you're creating geographic maps. Okay, there's a question here. What are the recession effects on data science jobs? Well, I think we have like a YouTube short video coming out about this, but quick answer here is that yes, all jobs, all domains are affected by the recession. However, data science actually becomes more important during a recession because data-driven decision-making and prediction can allow businesses to cut costs and increase efficiencies. So in that sense, data science becomes a little more important. And second, the number of data science people skilled at data science in the world is smaller than the number of data science job openings there are. So because the number of people that are skilled is still so small, so companies are still hiring for data science roles. Our hiring partners are still hiring for data science roles. And the third thing is that because data science is such a fast evolving domain, if you keep up and if you know some of the latest tools and techniques, you will never be out of a job because somebody will require that expertise. Okay, is data science needed? Does data science require an expert knowledge in data scraping? No. A basic web scraping, if you know how to load up a website, if you know how to extract information from a website, create a CSV file, that's enough. We have a couple of workshops on it. You can check out those. How to properly document projects. Okay. Well, so we have an entire lesson dedicated to this in the bootcamp, which is about documentation and storytelling. But I'll give you a quick overview. What you should do first is you should state the objective of the project. What is the problem statement that you're trying to solve? Then you should have an outline of the steps that are covered in the project. So step 1, step 2, step 3, step 4, you should have an outline. Then you should create sections within your Jupyter notebook using the outline. So you can use Markdown in your Jupyter notebooks to create an outline. And then inside each of those sections, you should have subsections. And in those subsections, you should have explanation before and after each piece of code. Okay. So check out maybe check out the credit card default payment prediction. So let me see if I can just share my screen, or I'll just drop it in the chat, but check out some of the example projects that we have shared and you'll get a sense of what I mean. Okay, next question. Is the pathway for data analytics and business analytics the same? Largely the same. For business analytics, you don't need to know a lot of Python programming. If you can just build business intelligence dashboards using Excel, Tableau, then you'll probably be fine. For a data analyst role, you will need to know a little more of Python and its ecosystem of libraries. How to publish my project online? Well, just go on Jovian.ai and you can click new and you can upload your Jupyter notebook, or you can go to medium.com and do a blog post. So yeah, those are both ways for you to publish your project online. Can you recommend places to publish our projects? Well, so put up your projects on Jovian. Add those projects to your LinkedIn profile. So you can feature some projects on your LinkedIn profile. Maybe also put up those projects on GitHub. So you have a way to send your Jovian projects to GitHub. And that's it. You can create a personal website if you want, but that's not really necessary. Okay, I'm trying to cover as many questions as I can, but if I'm missing your question, please just come back and drop it back in the chat again. Okay, what is the price structure for the bootcamp? So you can go to the website jovian.ai and you can check out the pricing structure. But I know that we have plans where you can actually pay equal monthly installments and it's fairly affordable. It's probably like the size of your grocery bill or something like that. So it's we've done our best to make it as easy for you to pay for it as possible. So do apply and check out our pricing scheme there. Okay, can I switch from software engineering to machine learning? Absolutely, you can absolutely switch from software engineering to machine learning. A good transition role would be machine learning engineer. So do get in touch with us. If you learn the right skills and then you build a couple of machine learning projects and maybe also do a project where you're taking your machine learning project and then deploying it to the cloud, then you can go into a machine learning engineer role. Can we apply for this course if you're in the first year of BTech Computer Science? Yep, by all means, go ahead, you can apply. Although I would say that it is going to be the most useful for you in your third or final year of college. Third year because you'll be trying for internships, final year because you'll be trying for jobs, but doesn't hurt to get started sooner if you have the time. If you can go through, we have a 14-day free trial as well, no questions asked, refunds. So you can go through the first couple of weeks of the bootcamp, and if you feel that, okay, you can digest all of it and you can actually apply it and you have the time to work through it, then please, by all means. Are your courses based on text or video based? Okay, yeah, we have all the courses have like detailed video tutorials and detailed written notes that you can follow along with. And we also have live sessions where we walk through the material, and we also have like live Q&A and things like that. I'm confused between software development and data science, which will be a good option. I just started my career. I would say try out both, try out a bit of both. If you want to try software development, check out one of our tutorials on web development. So we have something on, or you can check out any tutorial online. And data science, check out our course, Zero to Pandas. It's a free course where you can just get a small flavor of what working in data science feels like. See which one interests you. Both of them are great domains to work in. I personally have worked in both domains. I have great love and great respect for both of those domains. I'm planning to go for a master's in data science. Should I join the bootcamp? Absolutely. If you're going for a master's, okay. For anybody who is planning to go for a master's, here's something you should know, that when you go for a master's, you want to optimize, because you can only do one master's. So you want to optimize the university that you're able to join. So you want to aim for the best possible university, and you want to optimize the outcome that you have after the master's, which is the job that you get. Now, to get into a better university, when you're going to submit your application, it's going to really help if you mention that you are already enrolled into a data science bootcamp and you already have a lot of the skills that they require, and you've already built such and such projects. Because when you apply to the university, they're going to see that, one, you're passionate about data science. You're not just randomly applying. And second, since you already have all these skills, you are going to do well in this course. You are going to actually make it through to the end successfully. So you will have a better chance of getting into a good university, number one. Second, because you have this background already, you have this foundation already, you will be able to perform better in university. Everybody has that same amount of time, but if you go with some preparation, then you will be able to do better. You'll stand out, you'll have better grades. And since you'll have better grades, that means you'll have a better outcome at the end of your university program, which is in terms of the job that you get. So yes, if you have the time right now, if you're going to join next year, we've had multiple people do this. They've joined the program, they've built some great projects, and then they've gone on to university, and they've always come back and told us that, hey guys, the courses that we've done with you have been so helpful, because now I'm breezing through many of my university courses. So yeah, you should definitely join. You should check it out. And happy to talk to you one-on-one about that. Can we become a data scientist with just a bachelor's degree, or is a master's degree necessary? No, just a bachelor's degree is sufficient. A bachelor's degree, preferably in a STEM field, science, technology, engineering, mathematics. But we've also seen people from economics, commerce backgrounds get into the domain. What you need to do is learn the right skills, build these kind of great projects, and then publish these projects online, create a resume, and then apply. It's a step-by-step process, but you can absolutely do it with a bachelor's degree. What is the minimum salary I can expect if I'm switching domain from software development to data science? And what is the future of data science 20 years down the lane? Okay, two-part question. First, minimum salary, it really depends on what you're earning right now, what kind of role you're transitioning into. But at Jovian, typically we see, for somebody who has some experience in computer science or software development, salaries range from 12 to 20 lakhs per annum in India. Of course, country-wise, that can differ. What is the future of data science 20 years down the lane? So the entire world today is moving towards data-driven decision-making. The top companies in the world, all the tech companies, of course, they're a little bit down right now, but they're still the top companies in the world: Google, Microsoft, Facebook, Apple, etc. The entire companies are built around data. They are taking the data from users, they're analyzing that data, they're training machine learning models on the data, they're training deep learning models on the data, and all their products are powered by data. Google calls itself an AI company, and AI is built on data. So those are the top companies. Now you have all of your Fortune 1000 companies, all of whom are making this transition towards data-driven decision-making, transition towards artificial intelligence, and that is going to happen one way or another in the next 20 years. So every company is going to require data analysts, data scientists, machine learning engineers, and every company is going to require, in fact, every role is going to require some amount of data science. So that's something that we have to understand, that is a natural progression of the world. So data science has a great future. I wouldn't worry about it being the wrong decision. After completing the bootcamp, what post will I get? Do we directly go into the data scientist position? Okay, so the hierarchy of positions in data science is, you typically start out as a data analyst, where you are analyzing data, you're not really training machine learning models, but there are some exceptions here. If you do not have any background in programming, if you do not have a lot of background in mathematics, then data analyst is a position to start at. On the other hand, if you have a strong background in programming, or if you get really good at machine learning, so we have had people who have been, so a lot of people, machine learning is a bit of an advanced topic. So if you're able to pick it up within the bootcamp, and if you're able to build great projects in machine learning, and if you're able to then convey that mastery or machine learning in an interview, then you can definitely get into a data scientist role as well. However, I should mention that for data scientist roles, typically they will either look for some experience in the data science domain, which is as a data analyst, business analyst, etc., or they will look for maybe a computer science degree or strong programming experience or strong maths skills. right? So one of these, so the most realistic path for most people is to go through the bootcamp within that 6 to 9 month period, move into a data analyst role, and then within 6 months to a year, move into a data scientist role, either within the same company or within a different company, right? So that's the most realistic path, but we've had people who have jumped directly into a data scientist role, and it really depends on how much effort you're putting into it, what kind of projects you're building, and how well you're understanding all the concepts, right? It's like your future is in your hands. We're sort of enabling you, giving you all the resources and helping you in the process. What level of expertise is required in the tools and technologies used? Python, SQL, NumPy, Tableau, etc. Before starting this course? Zero. So this course has zero prerequisites. If you are, if you know a little bit of programming, that's good. Even if you don't, that's fine. We have enough time for you to catch up and enough resources, enough practice material for you to build up. So we've had people who've not had any programming experience, and by the end, they were able to build these huge projects in machine learning, right? So, but there are no prerequisites as such. But if you have some programming, maybe some mathematics, some statistics background, that's good to have. How to publish my project online? Well, you can go on Jovian.ai and you can say new notebook and you can upload your project online. Can I switch from civil engineering to data science? Yes. Many people have done that already. Just go ahead and you can just go ahead and apply to the program. Talk about Galactica by Meta. Okay, probably not relevant today. Is it a good idea to learn projects created with R2? It depends. Now, if let's say you're based in a certain in a country, or you're targeting a company or a domain where R is the preferred tool, then absolutely you should build a project with R. And here's how you can figure this out. Just go online on LinkedIn or AngelList or any other job site and search for roles like data analyst, data scientist, and look at the first 10, 15 job results and read through those job descriptions. In those job descriptions, they're going to mention the exact set of skills that they require. Now, if in your location or in the jobs of your preference or the jobs in your domain, you find a lot of companies mentioning R, then you should learn R. And if you find a lot of companies mentioning Python, then R is not necessary. So that's the first part of the answer. Now, the other thing is that if you learn data analysis and visualization, maybe machine learning with Python and Python's ecosystem of libraries, then doing the same thing in R is going to be really easy. Being able to build a great exploratory data analysis project requires learning a lot of concepts and requires learning a few skills. But then being able to do a second project in R is only going to take you a week of learning R, because you already know how to write code. You already know how to work with data. You already know how to ask questions about data, how to visualize data and things like that. All you have to learn is the syntax of R. The pandas library in Python is actually inspired from data frames in R, in the R language. So once you've learned pandas, learning R and using R is going to be fairly straightforward. And we've had people do that. We've had people who did the bootcamp and joined a company, and the company required R, and they were able to pick up R in a few days. Okay, what is the difference between EDA and data visualization? Are they the same? So EDA refers to exploratory data analysis. So it's the entire process of getting some data and then cleaning it, preparing it, analyzing it, visualizing it, and asking questions and deriving insights from the data. So you're exploring the data in all the ways possible using the tools at your disposal. Data visualization is one part of it, which is data visualization specifically means creating graphs, visualizing data, right? Creating charts, interactive charts and things like that. So that's, yeah. Okay. IIT Mandi also provides a course in advanced certificate in data science and machine learning, and their fees are the same as yours. They provide more modules. Yeah. So there are tons of courses online, right? And you should make an informed decision. So here are just a general tip in terms of what you should look for. So the first thing you should look for, I know that IIT seems like, okay, IIT Mandi seems like an interesting brand name to have a certificate from, but here's what you should look for. First, take a close look at the curriculum. What are you going to learn in the curriculum? And take a look at the projects that you're going to build. Take a look at maybe some example projects that people have already built. See if you can find those example projects. If not, then ask whoever you're talking to, ask them to share some kind of projects that people have built. And we've shared a bunch of projects with you. You can look at those projects and decide if those are good projects or not. You can make up your mind. That's one thing. Second, try to get some taste of the curriculum itself. So in our case, you can go to Jovian. You can check out zero2pandas.com. In fact, you can check out a few lectures from our bootcamp for free as well, and see if the pedagogy, the style of teaching, if what we are covering makes sense to you, right? If whether you like it. Because if you don't like it, if you don't enjoy it, then you're probably not going to do it. So understand what kind of projects you're going to build, what skills you're going to learn. See whether the style of teaching, the curriculum, the instructor, all of that appeals to you, right? And only then you should really talk about, you should look at comparing costs and things like that. The third thing you should really look at is what have been the outcomes for the people who have gone through the program, right? So because ultimately, I'm guessing you are trying to learn this because you want to get a job. So you should go ahead, read some testimonials, read some outcomes, and do your research, make an informed decision. And if you feel that you would like to talk to us and learn more, then we are happy to talk. But otherwise, a bunch of great programs available everywhere. Can I switch from BSc Geology to data science? Will my undergraduate degree create problems while applying for a job? BSc Geology is perfectly fine. We've actually seen people from geology move into data science. In fact, there are a lot of great jobs within geology, within that domain in data science, specifically in oil and gas companies. So one thing that oil and gas companies are now doing is before they drill an oil well in a particular location, they use these sensors to create some sort of a map of the terrain. Again, my domain knowledge is very limited, but one of our students did this, so I can share his experience. So they create a map of the terrain, and now they're trying to use machine learning and deep learning to identify what are the right places to dig, or whether they should even dig at a certain place at all. So yes, there are a lot of applications, and you can absolutely switch into data science from geology. Okay, you talked about artificial intelligence business intelligence projects. Does that mean your courses include Power BI and Tableau? Yeah, we do teach Power BI and Tableau. So we have I just want to quickly share this. We actually have a detailed curriculum that you can download. So let's see here. If you head over here and scroll down, on here you have this download brochure. That is a PDF file that you can download. Let me just save that and open that up for you. And so here you can actually go through the detailed curriculum. Let's see. So program curriculum, this is the overall curriculum. And then here internally, we have phase 1 foundations, where these are all the topics. SQL and business intelligence. So we have 4 lectures on SQL, and then we have data analysis with Excel and BI dashboards using Tableau. And then here you build an interactive BI dashboard. Then we have some core skills, and then we have machine learning and career readiness. So yeah, you can check out all of this. It's all in the brochure. So just go ahead and click download brochure here. Okay, what else do we have here? Let's see. Thanks for all the great questions. Do we require MLOps knowledge? Not in your first role. So MLOps knowledge is useful. MLOps knowledge, once you get into a machine learning engineer or a data scientist role, it will be useful, but not in your first role. What would you say, Python versus R for machine learning? Absolutely Python. Python is far more versatile, powerful, widely used. R is a great language, but it's just that Python is more popular. How do you execute a Python .py file? Just type Python file name .py, and that should run the code for you if you have Python installed on your computer. Can I apply for your placement facilities if I have the projects and skills by paying a certain amount of fees? Well, we'll have to see. I would suggest maybe email me. So I'll just drop my email in case anybody wants to email me with this specific question. I think that's something that's better answered one-on-one. Email me with your resume, and then we'll see what we can do. Yeah, we have an exclusive job board from hiring partners just for graduates from the Jovian Bootcamp. Okay, let's keep going. What should be my roadmap for master in mathematics to ML? Okay, you want to move from masters in mathematics to machine learning? Well, I think largely the same as the roadmap that we have, which is learn Python programming first. So learn how how to turn your thoughts into code, how to solve Python problems using Python. Along with that, learn SQL, learn business intelligence tools, then learn NumPy, Pandas, and data visualization tools, build an exploratory data analysis project. You may not need to spend a lot of time in statistics. We have a module on statistics, so you can probably spend that time more on honing your data analysis skills. Then focus on machine learning, especially if you have a good maths background, especially if you have a good understanding of calculus and linear algebra, then you should be able to pick up machine learning in a fair bit of depth, and you can probably try for a data scientist role directly. Okay, is age the criteria for doing a transition from non-tech to data science? Nope. We've seen people from the age of 20 to the age of 35, 40 even, move into the domain. Of course, at the age of close to 40, the number of opportunities that you will have are going to be slightly limited, because not every company is going to hire for a data science role, a level 1 or level 2 data science role, somebody of age 40. Not every company is, but there are enough opportunities there. You just have to keep looking. You just have to find, and you have to have great projects. You have to prove yourself, right? But age is not a criteria for making the transition. I would like to know how to execute .py files in, okay. Mandeep, you can just maybe email me with your question and I can get back to you. Can I attend the bootcamp in flexible hours? Yep. So 80% of the time you're actually working through the material by writing code at your own convenience. Only about 20% of the time is attended in is spent in live sessions. We've tried to reduce the amount of time for which you need to be present live to an absolute minimum, so that you don't have to spend a lot of time there. Is age a barrier to get into data science? I have 13 years of software engineering experience. I am 37. Yeah, I think if you have several years of software engineering experience, then the role that you should be targeting is machine learning engineer. And the way you should do this is do the bootcamp, especially focus more on the machine learning part, and build a great machine learning project and then deploy it using your software engineering skills. And then you will be in a good position. So I think it'll take maybe another month or so additionally, but I think it's going to be totally worth it. R has 3 windows, 1 to execute. Okay. Okay, so there's something about R. Yeah, that was just a comment, I believe. I want to know how to make an end-to-end project and what it means to have a good end-to-end project and what a project could be is in relation to complexity of problem. Okay, so Kishore, since you joined late, I will suggest that you check out the recording, because that's exactly what we have covered. And on our YouTube channel, we have tutorials on how to build projects from scratch. Okay. All right, what else? Already enrolled in the data science in other college. Do you have any course bootcamp only for projects? No. If you want, so see, if you want to build the projects, you should join the bootcamp, right? Because that's the projects make up the output of the bootcamp anyway. So if you want to build these projects and you feel that wherever you're enrolled or whatever you're doing is not serving your purpose in building projects, then you should just join the bootcamp. But I'm sorry that unfortunately you had to enroll into a program which is not giving you this practical knowledge. But yeah, do talk to us. Again, you can email us and we can see here. What we can do is that if you already have a certain set of skills, then let's see, we'll have to discuss with the team. Happy to support you in whatever way we can. Let's see if we can make some accommodations, but please email me with your resume and the information and I will get back to you. Is there any difference between data science and machine learning? Yep. So data science is this huge domain which includes data analysis, visualization, a bunch of other stuff. Machine learning specifically is about creating predictive models. For example, credit default prediction. Can you create a system that can automatically predict by looking at old data, that can it automatically predict where somebody applies for a credit card, are they going to default on it or not, right? So it's about that automated prediction. That is what machine learning is. Any chances of doing an internship with you after the bootcamp? Well, yes, people have done internships with us. People have done internships with our hiring partners. So we facilitate internships as well. So we have a private job board. Let me quickly show that job board as well. So let's see. So we have a private job board here for bootcamp participants. People apply even before they graduate. And for all of these jobs, so you can see these are some of the roles open with our hiring partners currently, and we are constantly reaching out to more companies, and we are constantly revising the set of jobs we have open here. But but all of these companies are generally also open to taking interns. So if you don't have any experience in general, or if you have very limited experience in data science, you're open to doing an internship, and most of these companies are open to taking interns as well. So people often do interns with these companies too. Okay, what will be the most focused subject in your bootcamp? I mean, data science, machine learning, AI. Okay, so the crux is data analysis, visualization, and machine learning, right? Because data analysis and visualization, exploratory data analysis, that is one very important skill that you will need for any data science role. Then SQL is going to be a very important part, because that is something that is not only required for data science, but is also tested extensively during interviews. And then machine learning, which is, we don't go too deep into machine learning, because in your first data science job, you will not be applying machine learning, and we have more advanced courses on machine learnings. So that's something that we don't go very deep into, but that's the focus of the bootcamp. See, the idea is that you want to break into data science, you want to get your first data science job. What is it going to take to get your first data science job? We've looked at hundreds of job roles. We've seen hundreds of people go through this process, and we've identified the exact set of things. And once you get in, you will, of course, move up. Okay, couple more questions. Will there be a bootcamp on AI? Yep. So we are working on an advanced machine learning bootcamp. That is something that we'll release soon. But I would say that if you're not already working in data science, maybe the advanced stuff may not be appropriate for you. If you have already started your career in data science, or if you're already working as a software engineer, maybe then that will make more sense. But first, you want to gain the basic set of skills, and you can learn it in the next 4 to 5 months. So I think you should build that foundation if you don't have that already. Do the hiring partners offer paid internship programs? That depends on them. Many of them do, some of them don't, but it depends on them. But really, with an internship, whether it's paid or unpaid, really should not affect your decision, because you are doing an internship for the purpose of learning, and you should focus on optimizing your learning. So I would say, if you have an unpaid internship where you're gonna learn more, prefer that over a paid internship where you won't. Do you provide 100% guaranteed placement? Yeah. So if you're based in India, we are, for a limited time, offering a job guarantee program. So we've seen that if people who graduate from the program, we've had a huge success rate, like 85% or something of them end up getting a job within a few months. So we have this job guarantee program in India. You can check out our website, and you can also just reach out to our academic counselors. Do you have scholarships in the bootcamp? Yes, we do for students, or if you have really good grades in college, you can send us that information. So yes, or we have some scholarships for women. So just apply to the program, get in touch with our academic counselors, and we also have a specifically a discount or a sort of a promotion running for people who are attending this webinar. Basically, what we're trying to assess is two things. Well, how interested and passionate you are about getting into data science, and second, how likely you are to succeed based on your commitment, based on your sort of past history, etc. Right? And if we see those two things, then yes, we can make some accommodations. Okay, if I've not been able to get to your question, please drop me an email. Again, I will drop my email in the chat. It's just aakashns@jovian.ai. You can drop me an email, and either I'll answer it, or I'll put the right person from our team in the loop so that they can answer your question. Do you think a PC without a GPU can be recommended? Yep. So I don't have a PC with a GPU. I use cloud resources. If you check all of our courses, we use cloud resources now, because there's such great cloud resources with everything set up that we generally don't recommend doing things on your computer. And that's really never a factor in the quality of the projects that you build or whether you'll be able to get a job. So yes, you don't need to have a PC with a GPU. If one enrolls in the bootcamp, can one complete it at one's own pace, or everyone needs to cover things at the mentioned speed? Good question. So we do have we run batches of bootcamp starting every month. And what happens is every week you have certain lessons to complete and deadlines to meet and assignments to complete. And then after 6 weeks, you have 2 weeks where you have to work on a project. And then there's a break week. And then we go on with the next 2 courses. And then again, we have lessons, assignments, and then we have projects, lessons, assignment, projects. Ideally, you should be doing it in a 6-month period. Ideally, if you're spending 16 to 20 hours per week, then 6 months is more than enough. In fact, in month 4, you'll actually be in a position that you'll start applying to jobs, and you might even be placed by the 6th month. So that's the ideal setup, but we know that life can get in the way. We know that sometimes people want to take a little more time with some of the material. So if you need, we can always extend it slightly for you. And the way we do that is, let's say you joined in the March batch, but you've kind of fallen behind a little bit, then we just move you to the April batch. So each course is starting a new batch every month. So if you've fallen behind in a course, you can just drop out of that course for a bit and then join back in the next batch. Okay, I think we have answered all the questions here. Mandeep, I can see your comment here. You mentioned that you are 47 and you're looking to break into data science here. I think I would love to chat one-on-one. If you can drop me an email, and this goes for others as well. If you can drop me an email, if you have questions about the program, you can drop me an email. I will get in touch with you. Maybe we can also have a one-on-one chat. I have these slots open for one-on-one calls. So I'd love to chat one-on-one, regardless of whether you join the bootcamp or not, or you should join the bootcamp or not. Happy to just chat and share insights from what we have learned over the last couple of years running these kind of programs. I will put my resume and I want to get scholarship in your bootcamp. I am very interested to do a project and apply. Okay, so please send out an email and also just fill out an application. So in any case, I would suggest filling out an application so that you can also talk to our academic counselors, but you can also send an email to me. You can just mention that I attended the webinar, and we will, we'll do something. We'll see what we can do, right? We have limited seats, but and I don't think we're doing a batch in December. So if you want to join, then like the November batch is kind of getting started next week. So yeah, please email me and we'll see. We'll figure out if we can make it happen. Okay, I think that covers all the questions. So thank you for joining. I hope this was helpful. Can I get a quick yes or no in the chat? Was this information helpful for you? Okay, perfect. Yeah, great. Also want to understand what topics would you like to hear about? What questions do you have about data science that you would maybe want us to create a webinar about? We'd love to hear from you. We'd love to understand what is it that you need, and we are happy to support you in that process. Any suggestions? Okay. All right. Well, I'll let you. We'll send out an email as well. You can always email us with suggestions. Okay. Bring in industry experts. Yep, that is happening. That is coming soon. We are in talks with people. All of the projects, separate paid courses on BI tools. Okay, we can talk about that, but we like to structure it like a program because we want to tie it to the outcome. A course is fine, but really what we want is, you to be able to move into that domain. Okay, building a profile for an MS PhD in a data science. Okay, that's a good one suggestion. Thanks, Weber. One suggestion is building a profile for an MS or a PhD in data science and machine learning and AI field. I think that's a good topic for a webinar. We've actually helped a few people with that. So how to showcase skills in SQL. Okay, well, really you just get enough practice with SQL and maybe just do like a SQL come BI kind of project. CV review to get a job. Okay, how to build a resume for data science. I think that's something that we can do. All right. Well, thank you. Thank you for all the participation. Thank you for joining. I know for some of you, this time is not convenient. So we really, really appreciate you joining. And we will send you a recording of this webinar. We'll send an edited recording, but we'll send you a recording of this webinar, and feel free to continue joining webinars. Feel free to continue taking our courses. And if you want to get into data science, then go ahead, at least apply to the bootcamp, and we'll see how we can best help you. Further, the recording will be sent soon. Thank you. Thank you all for joining, and I'll see you in the next one. Bye.